Yes. It is now time for an insightful session by Professor Alberto Borghetti. He'll be introducing the course and discussing new challenges in the distribution system planning and operation. Let's welcome him with a round of applause.
It's good to receive the applause before, because after we don't know. So I'm taking on. I would like to thank to you to join this lecture. I will try to manage at the beginning how to do, and then also a brief introduction of the course, a brief introduction on me or to my institution, and what we are dealing with. So electrical power. The first lecture, I will try to summarize a little bit a view of not only of distribution system, but in general of the power system. So this is the introduction for my institution at the University of Bologna, Italy. You can see some images. One is the old one, because they say that this university, I'm not, probably there is something that, yeah, probably here is better. Yeah, good. We need to arrange. This is the old image. Yes, no, that I was aware of it. This is it is the building, 15th century building, and that is still the rectorate of the university. This is the image now of the center of the city. The city has not a nice campus as this one, as VNIT, that is separated from the city. It is spread around the city. The city has more or less 300, a little bit probably more, but not much more than 300,000 inhabitants. How many students? 90,000. So 90. So you can understand that most of the people are related with also with the university, and the students are a large part of the people inside Bologna. In the summertime, in August especially, there is a vacation, so the city is empty because there are no students at all. This is the image of also this position. Where is Bologna? Is in Italy here. So you have some other cities to have orientation, and this is Italy, and Bologna is here. So in the northern part there is a plain here, because there is the longest river in Italy. It is called Po, P-O, just Po, and it is the long, and there is a plain here created by the river in the centuries, and so the Bologna is here in the middle of this plain. There are mountains in the north, the Alps, but also in the central part, the Apennines. So it is a plain in the middle. I would like also to put some dates here that these are the number of students. You see nearly 90,000. And international studies students, there are several, that are coming also from India and other yes, far away. Yes, I have some. Oh, I do apologize that I need my laboratory. I'm working at the laboratory of electrical power system. This is the website. It is a power system engineer laboratory. It is focused on generation, transmission, distribution of electricity. And so these it is part of the Department of Electrical Electronic Information Engineering, and these are just some of the ongoing projects that I can mention in order to understand our activities. We are involved in a European project, high efficiency transporting electronics component system for the next generation of energy supply infrastructure, and that has been recently concluded and followed by another one, electronic components for system for flexible, coordinated, resilient. I do apologize. Resilient distributed renewable energies. And then another one that is most focused on the hydro power station. So store to hydro, novel long-term energy, electricity storage technology for flexible hydropower. It is coordinated by people from Norway, because in Norway there are a lot of production of hydropower and so on. So they are very expert and they are very focused on, exploiting the possibility to store energy in the hydropower station. And we are mainly focused on the exploitation of small hydro station at the level of distribution network. So for the connection of the photovoltaic solar and so on. There is also another project coordinated by one of my colleagues that is smart or sustainable mobility. So it is mainly focused on electric vehicles. These are the courses that are taught in English. Some of the courses also are taught in Italian, but we have some courses in English: climate neutral, smart city and energy communities, electric power system for mass city, electric power system for sustainable mobility, smart grid for renewable integration. I am teaching electric power system, that's without color. In the website that is LISEP, if you have the possibility to connect and so on, there is also the list of our publication. Several you can directly download. If you have any difficulties, you can also mail me, but in general, they are available. But I think that we can probably just, but I don't think that we have any problem. So these are also the people. Thank you so much. I'm disturbing you every time. These are the people of the laboratory. You see that the number of people is quite limited. It is in the small group. There is it is the coordinator, also my mentor, Professor Carlo Alberto Nucci, myself, Fabio Napolitano, Fabio Tossani, Stefano Lilla, and the PhD students now. Some are coming also, and Toida Righi, Prevedi, and Ali Ahmadpour. I don't know if it is good at this point to have an overview of the course, and I would like to say to the attendee that you can interrupt at any time if you have any questions or any curiosity and so on. So please feel free to stop me, even if you can be near here and not in the back. Probably it is better. I don't know if you can move also after the lecture. In the places, so we can communicate at little in an easier way, rather than to be at some distance. So
they are maybe hiding from your vision.
Pardon me?
They are maybe hiding from your vision. That's why they are on back.
They are on back because there is no
forward.
Possibility to see me. I see. Thank you so much. You are getting points. The closer. Thank you very much. But also after, no, we don't need.
They are our own students, own anything students.
Good. I don't know if we can give an overview of the course, but probably you can give better than me. We have imagined this course separated in until Friday, no, in several days. So today is more on the introduction, and the afternoon is devoted on a specific topic, that is the protection from lightning of distribution network. We are not dealing much on protection in this course, but we just compensate a little bit this afternoon. And then the second day is devoted mainly on the possibility to organize in the distribution network somehow a market or the possibility to exchange power from the users that are connected in the distribution network, that are provided by generating facility or also storage facilities, and others that just consume. So why why not put a framework or a regulatory framework that allows the people to directly exchange power, also money, from them in order to a little bit decrease or try to decrease the price of electricity. Italy is mostly affected by this because the price is very high, just in this way. Then the other days are devoted mainly on distribution load flow or optimizing algorithm, also meteoristic, and energy management, integrated solar photovoltaic. Then there is a day that is mostly devoted to electric vehicles and also voltage control or distributed voltage control. And then there is a last day that is flexible operation, reconfiguration, and microgrids. Probably we will join these two parts in one, and also questions, open questions from you. During the course, we will try also to organize some laboratory, but without leaving this room. So I will just try to do something with you with your laptop that you have and so on. Any questions so far? No. So, the introduction of power system. We can also think about, I need to sit. The power system, very simple with a generation, and I need to probably to find the position in which this is not. Okay, we can say that a power system is just a generation and some loads with some distribution network. This is the typical also, framework of some simple power system that are this power system in a ship or just in a satellite or in an airplane, no? Very small and so on. In general, we are dealing with, in this course, not so simple system, but are in general not simple at all. I mean, because they need to work isolated, but with this kind of a situation. So the power system that provides electricity to the final users. So in general, this is the classical view of transmission and distribution, and then utilization at the end. With the transmission that is separated by the voltage. We in general classify the appliances and also the lines and so on according mostly to the voltage rather than to the power, to the current, or to other parameters that are obviously are very important. No? And this is because, if you have a line of 130 kilovolt, and you want to replace that line with a line of 220 kilovolt or 400 kilovolt, it probably, even if it is on an overhead line, you need to destroy all the pylons, all the towers, and replace them, because you need to increase the distance between the conductors, because you need to increase the insulation level of the line. No? And so it means that the voltage. Oh, thank you so much. Many, many colors. Good. I'm so happy. Thank you. So it means that the voltage characterized the system. So the system in general is characterized by the voltage. The power is also a very much important characteristic, but if you have a line that can carry 300 megawatts or MVA, and you wish to increase the power in that corridor, probably you don't need to increase or to replace the line. Probably you need to build another line in parallel, so you can transmit more power or the cables and so on. So this is the idea that we have in mind when we characterize the voltage. You see here the typical voltage in Europe, in Italy. That is 400 kilovolt for the maximum level. And there are also lines that were built before the 400 kilovolt level. So in particular in Italy, 220 kilovolt. This is the transmission network. For sure, in India, there are lines with higher voltage, and in other parts of also in Russia, for example, or in United States, or in Brazil, or in China, there are lines of 765 kilovolt, also above, also 1000 kilovolt. And this is because the average distance between the generation and the final use of electricity, it is much shorter in Europe. That is a small, continent with many cities and so on. So the average distance between the power plants and the cities is reduced. So we don't need to build lines with a very high voltage. Whilst when the distance between the generation and the consumption is much high, you need to build lines with a high voltage. Everybody aware why we need to increase the voltage when the distance between the generation and the consumption is much long? Perfect. So we need to say that the losses does not depend on the voltage. If you have a resistance at level of 1 volt or 100 kilovolt, the losses inside the resistance are depending on the current that is going through, not at the level of the voltage. So since the losses are depending on the square of the current, we want to transmit the power at the lowest level of the current. So we increase the voltage when the distance is important. Otherwise, the most of the power is going into the line. So we have this transmission network, and in general, all the big power stations are connected to this transmission network, and but then near to the cities, we reduce the power and we distribute the power, we reduce the voltage. So there is a medium voltage level. Typically in Italy, it is between 15, 20, 23 kilovolt. I know that in other countries it is different. So the level of the voltage is quite different. So can be also at the level of 30. In general, what distinguishes distribution network from transmission network is that in general transmission network is very meshed, and distribution networks in general are at least operated radially or as far as possible, with some exception. And then there is the utilization at the low voltage. The voltage in Europe is the same as in India. I think 230, 30 volt, line to neutral, and line to line is 400 volt. Oh, here in this picture, it is quite traditional. There is something can be new. I mean, there is an increased use of HVDC, so connection in DC, because all the system is in AC, so alternating current, so 50 Hertz in Europe, also 50 Hertz in India, other parts in 60 Hertz, in particular in America. But there are some links that are under the sea. And so under the sea, it is better to, I mean, you cannot build the line in AC because cannot be overhead, needs to be cable, and the greatest difference between cables and overhead lines is that the cables have a shunt capacitance that is much higher than the shunt capacitance in the overhead lines, 15 times larger. So it means that when you have a cable in AC, there is a percentage not negligible of current that is flowing through the shunt capacitance rather than reach the end of the line. So if the line is too long, I mean, nothing is reaching at the end. And so you need, in general, to switch to another technology that is much more expensive, that is the HVDC, so high voltage DC. So it means that there is a power electronics converters at both ends of this link that connects the link in DC with the AC system. Do you have any questions so far? No. Good. I don't know if I have here written something, but I would like to prefer to skip a little bit these just words and go directly to a page in which there is something more appearing for now. So some website, and then we can come back. And I would like to start with this. Oh, I have already checked at the beginning this website. Oh, so sorry. Doesn't work now. Was a website of electricity map. Was okay, now it's working. electricitymap.com, and it shows apparently in real time the flows of the power between the. If it's not working, so what I can do? To do. Okay, so I can just skip this. And the zoom. So now you can see. Okay, thank you. So you can see here the slide with some website. I've put a collection of website in order to illustrate a little bit some concepts, and since it is in internet, probably it is true, no? And there is a website, I don't know if it is true or not, but it gives in real time the indication of the power that is flowing in the various regions. And one of the things, the color that are mentioned in this map, the green, this brown, and so on, are related with this concept of carbon dioxide equivalent in per kilowatt hour. Can you say to me why we are interested on how much carbon dioxide we produce per kilowatt hour when we generate electricity? Any of you have an idea why there is a map in this website? and they put a lot of effort, imagine, to collect all the data. Apparently, it is for 10 February, so it is for every day. Anybody? Pardon me?
Current data.
Current data, apparently. I'm not doing the task, but they say that in 72, and then there is also the data for 3 months, the average, no? And you see that they have put a lot of effort in order to characterize for all regions, but not only in Europe, this is Italy, of course, France, Spain, Germany, and so on, Poland, but for all the worlds. So for, okay, there are countries that does not provide the data, so probably, so also for India, no, you see, and you see that we are here, no, there is a 751 gram per kilowatt hour. This is the carbon dioxide, CO2, no, CO2 emission. Why we are so focused on CO2 emission? Is CO2 something dangerous? Is it something that is affecting your health? No, we are not producing also CO2, no? So everybody, so it is not a dangerous gas. It is not poison. It is not environmental. What is the problem for the CO2?
Global warming.
Perfect. So it is the greenhouse effect, no? The increase of the temperature in the planet. So we are increasing the temperature. So I would like to mention to you also one slide that I probably skipped at the beginning, this one, that gives an idea of the global greenhouse emission by sector in 2021, and you see different colors: agriculture, waste, building, industry, manufacturing, transport, but there is a part, large part, that is electricity production and also heating, you know, of the system. So you see that we are, I mean, focus. I mean, the people that says that in the planet we need to reduce gas house emissions in order to decrease the increasing of the temperature, the warming, the global warming. We need also to decarbonize, they said, so to reduce the impact of the footprint, they say, in the production of electricity by these power stations, no? So the power station, and you see that here there is another image that is the changing in the years, and you see that during the years from 2001 and 2021, there is an increase of emissions, so we are still increasing the emissions, and the part in orange is the part associated with electricity and heat, and it does not reduce so much. And you see that also here, you see that when we see the sources of the production of electricity from oil, natural gas, coal, nuclear energy, hydroelectricity, renewable. Of course, so we are increasing the production globally for all the world. And but there is an increase of the green part, renewables, but there is not a much decrease of the other parts. So still the production from coal, natural gas, in particular in Italy, oil is important. Yeah, so you can see also here that there are countries that are more producing carbon dioxide, and that are the brown colors here, and other countries that are very green, because the production is from, for example, I think hydropower. Nepal, yes, they are probably hydro stations, no? So probably this is the reason for the.
Most of the energies have been imported from India.
So good. So good. So you see that this happens here in India, and also happens in here, where in Italy most of, I mean, a large part of the production is from gas, so combined cycle power station in general, and also hydro in the north. So, and but there are countries that are very green, and this is the typical case of France. But France has not much hydro, has some hydro, in particular in the mountains, but most of the production in France is from nuclear power station. You see, there are countries that are extremely green, that are the northern countries, Norway, Sweden, and also Finland, but in particular, they have both. They have both the hydro, in particular Norway, but also the nuclear power station in Finland. I would like to mention, if you have any question or any suggestion or anything, you can stop me. I would like to see also another website here in the list that is in the structure. I'm starting with Europe because I know a little bit better. I don't know. It is here. So this is the network in Europe. This is the website of the European Network of Transmission System Operators. So every country has a system operator. There are countries in Germany, there are 3 system operators because Germany was previously separated, so was joined, so and it is a big country, so there are 3. And in Italy there is only one transmission system operator. They operate the network, but there is also a coordination between them, and this is carried out by this ENSOI, so European Network of Transmission System Operators. This is the grid. It is all synchronized, so all are connected in synchronism, and it is not only European Union, it is behind, because it goes from Portugal to Turkey. Turkey is not part of the European Union, but it is all interconnected. And it is interconnected from sometimes also Ukraine, in order to help them for political reasons. It is connected also the England, so United Kingdom, the northern countries, and in these days, probably in this actual today or in this week, I know that they are connecting in synchronism also the systems in Lithuania, Latvia, Estonia, so these Baltic countries, to the rest of the system. Previously, they were connected to the Russian system here. You see that different colors. The color in red is for the network of 400 kilovolt. So there are also here in green some lines, some network that is the old network of 220 kilovolt that is still in operation. And you see, this is Bologna. So here it is my city. And you see also these colors here under the sea, from Italy to Montenegro, Italy to Greece. And also there is this link, this is Sardinia, so still Italy. It is the island and the continent. And these are HVDC lines that are cables that are under the sea and are connecting the other parts. There are a lot of work, also now I can also imagine here to build new lines. For example, here you see that this is not a continuous line, solid line, but it is dashed because it is under construction. It is the connection between Greece and Crete, the island, and Crete and Cyprus here. And I have seen also some projects to connect this to another electrical island that is Israel, because there is no connection to the other. So from Cyprus to Israel here. There is a site here that gives to you also some data about the system if you want more. It is the new transparencies in ENSOE. So it gives some indication of, for example, the load, the generation, probably also the price in the various zones of Europe. And this is for example, the load. The usual curve of the load, you see it is for today, says 10 February, and there are two curves, so one in green and one in red. What is the difference? I mean, why two curves? Any indication? Yes. It is very important for the transmission system operators to know also the future, because they need to arrange all the system of dispatch, all the units, in order to cover the future consumption of electricity. So for each day, in particular the day before, they try to understand which is the behavior of the load in the next day, in order to be prepared and to dispatch and to put in operation the power station, the power plant that are needed. And you see there are two curves. One, it is for all the day, with the typical behavior, with the peaks in the morning and also in the late afternoon. And there is another curve that is the actual load. So as far as this red curve is near to the green curve, then everything is following the expectation. So there are no unexpected events or something like this. When the two curves are very different, probably they need to change in the intraday, not their decision.